Now we are having a panel discussion. I'll request Mr. Octavio and Mr. Uma Mahesha to join the panel discussion. Thanks again, Shar and Octavio, both of you, for your wonderful presentation. I have couple of questions for both of you. I'd like to start with Octavio first. So, in your presentation, you mentioned about end users as application co-authors, right? And how can end users work in this role, basically?
Hello, hello. Oops. Well, when you talk about the OPAS structure, everything comes from the OPAF, right? So something that I have already presented by you. But this forum is composed by vendors, integrators, and end users. And OPAS is an end user initiative. So we started 10 years ago with ExxonMobil. We have a couple players now as end users. So everything that comes from the end user is very important. But uh, in the subject of my presentation, uh, standard applications are there. We know them. We know how to do process control. And to have more flexibility in these applications, uh, the end users will bring these requirements to us, these ideas. As a flow computer was an end user requirement. They came to us and said, okay, we would like to test it. And because of this, we develop it. The same can come from different users in different applications. So this is why end users should be co-authors for that. Probably end users will not have a structure to develop by themselves, but they can contribute, and they will be. This will be very important if they can contribute, bring these ideas of how we can improve our Opal's applications to meet their requirements. So that's is important.
That's interesting. Thank you. My next question is to Uma Mahesher. So, in your presentation, you mentioned a lot of, let's say, niche skills and specialties. But my question is on that what is the future of flight and the role of AI in that future of flight?
It's a very interesting question. No, future of flight, as I said, is about sustainability. Yeah, we have at every point of time, if you look at, there was one underlying theme in when it comes to aviation industry. So it started with aircraft being used for wars, and it was all about power. If you look at aircraft engine, it was all about power, power, power. Even today, also in the military space, you see we need more powerful engine, right? So it started with that. When it came to commercial aviation, it was all about safety to make it more viable, and then it was all about affordability, which is efficiency. How do we improve the efficiency and reduce the fuel consumption? So that was the theme. So if you fast forward, if you look at during 9/11, right? I mean, the entire aviation industry, it was all about security in the airport. During COVID, it was all about health, the safety, but in terms of the health. So if you, at every point of time you have one underlying industrial industry theme, which drove the industry. But as I said, the future of flight is all about sustainability, whether it is about reducing the carbon footprint, whether it is about how do we make a sustainable supply chain. So there's going to be a lot of challenges around this theme of sustainability. And the industry is going to grow significantly, and how do we make sure that the aviation continues to be the most safest mode of transportation, which from being one of the most dangerous mode of transportation became the most safest mode of transportation by far. So as we introduce these new technologies, how the industry continues to be the most reliable, safer mode of transportation, but how it becomes more sustainable and more efficient. That is going to be the future.
That's great, Shay. Yeah, probably I'll ask one more question from my side to both of you. Then we can open up for the audience. This question is to Octavio. So you mentioned different advantages, but I want to understand the what advantages do you think these spatial applications can bring to Opus end users?
Well, the idea of special applications, the name is special applications. They are special because they are free to be developed, right? So the idea to have like a structure that can be configured to perform uh, personal, speaking of course in enterprises, personal requirements is something that can bring to the end user the capability to perform more on their pain points, right? It's not a matter to just have like a control loop that's well tuned, right? But is the capability to have this structure to develop something that will heal their pain points. So that's why these special applications can be important. We can, of course, start bringing uh, applications that were not explored by Opus yet, but the long-term, long vision idea is to have this capability for end user. So it's like the first question. The end user will be the co-author of the solving their pain points because they can bring the application, they bring the problem, can be solved by themselves if they have a structure to perform by themselves, or they can come for any kind of software supplier, uh, build their Opus application for their pain point, implement on their system according to the architecture, and then use for that. So it's like a mix between this question and the last question. Why end users are important as co-author, and what's the benefits to have the possibility to create these special applications.
Yeah, thanks, Octavio. I think I have another question for Mr. Momesh. It is, let's say, aerospace industry needs, let's say, means very niche skills and specialties, right? So, how is GE Aerospace looking at AI to help employees with their productivity?
Can I get repeat?
How GE Aerospace looking at AI to help employees with their productivity?
Okay. So I did mention towards the end that we have our own in-house AI platform called WindMate. So WingMate is based on our core flight deck principle, which is the operating platform of GE, you can say, which is based on, of course, Lean. So this WingMate platform is being used widely by our employees for personal productivity. So for example, we have a large amount of design data, manufacturing data, or the way we would have addressed certain the services related or maintenance related query. So we don't have to invent this knowledge. So employees can actually look at all the decisions that we would have taken for the similar conditions and just address this very quickly. So that's one way. The other one is what we see is the knowledge graphs, which I talked about. There's a large amount of knowledge that we can actually co-create, together as we are working on design development of, let's say, the next generation technology or next generation product. So there's a large amount of learning. So once the product is designed, you know what worked. So that's one thing. But when you are already working, there is a large amount of data, in process knowledge. That's another way our employees can actually learn. Say, hey, we tried these 5 things. Maybe this is not the best one out of these 5. This is the best approach. And that would be the approach which, other employees can actually follow without repeating, all the 5. So I see that there's a lot more in process knowledge that we can actually gain by using AI.
Yeah, thank you, sir. And probably we can open up for the few audience questions. Can we have, yeah.
Good afternoon. My name is Narayana. I head industrialization for new age of IoT products in Bosch. So my question to GE. So you have a vast data of data because 100 years of data you have. So how many dark factories you have for engines starting from a drone engine to mega engines you're producing? So how many dark factories you have and what is the target?
I know there's a lot of discussion on. So, it's not like a dark factory where, there are no employees, everything is robotic. We use in combination. There are a lot of operations which are highly precision oriented. Not now. For many years, we have been using robots, for example, a lot of automation. So I wouldn't say it's a factory with complete, like it's a dark factory with no humans. That's not the scenario. In fact, one of the things which I highlighted was that we cannot take human out of the loop. So it's very important that we have human intervention at every stage. So we are not come to a point where you can completely automate aerospace industry with dark factories. Not yet. Not yet. But we can use a lot of automation, a lot more sophistication, a lot more robots, which can do a lot of tedious activities or some of the activities which are otherwise humanly not possible. Hope that answers.
Yeah, thank you. Uh,
Good afternoon, sir. Myself, Rajkumar from L&T Technology Services. So actually, using AI in low-end jobs, right? For example, legacy CAD conversions or EC and ECR, where we are able to develop models and able to achieve accuracy 85% or even achieving the productivity 25% is possible. But when it comes to design, complex designs like aerospace, how you are able to effectively leverage, because as you said, right, you are able to optimize number of iterations in CFD, FEA with the help of AI, right? And for example, some of the complex design, okay, AI is able to do a generative designs, multiple concepts is able to provide. But when it comes to design for manufacturable, we see a lot of gaps there. Probably, I mean, how you are able to impart that domain knowledge to the AI so that it's able to have the product designs from the manufacturing perspective. Or for example, if you talked about the additive manufacturing, right? In aerospace, you need lot of parameters need to be considered. As you said, you need to have lightweight, you need to have the power, efficient power, right? So how do we leverage AI in the design perspective, especially complex products like aerospace?
Yeah, that's a great question. So there are two, three things in this. One, can you upfront design a product which is manufacturable or design for manufacturability, in other words? I think there is a large amount of work which is already going on, which we do in G, where you know what is producible, what is not producible. That data is available. If you can integrate that into the design and the simulations, you can actually say that, hey, for example, this fillet of, let's say, turbine blade, right, when we manufactured our legacy knowledge shows that beyond certain, say, if this fillet is not manufacturable. So when we design, upfront you say, this should be the max min limit of that fillet. So you design for manufacturability, or in the optimization, you can include those constraints. That's one. The other one is in-process manufacturing. I think it is there everywhere, right? You can have the predictive maintenance of machines. You can pretty much control the inputs of the machine so that you know what would be the output from the machine, whether it is in terms of the surface roughness or the tolerances that you can achieve, which is function of the machines and the conditions. It's very widely used in additive manufacturing. So GE has additive business by itself. So where we can monitor the in-process parameters which are directly related to the end product coming out of the additive manufacturing. I think the same methodology is being used for other conventional manufacturing methods. And the third one is around the how do we use large amount of manufacturing data and integrate with the entire life cycle of the product. So for example, when we have to take decision on a particular part, I would like to look at the design data, the manufacturing data, and how the part is there in the field together, right? So we can integrate this entire data together and see how we can put some limits on the manufacturing aspects. So I think the possibilities are multiple, but I just shared few. Thank you.
Yeah, thank you. Can you have mic back, Shait, first one? Okay. Okay, you go ahead first.
Okay.
Keep your question little brief so that we can get that.
Yes. I'm Gayatri. I'm coming from Chevron. My question is to you, Mr. Roma, on the sustainability. See, when it comes to the sustainability in an enterprise, when we have a lot of POCs that we do and when we enter into a scalable phase, the first thing is how do we capture the value for the work that we have done, so that quantifies, to continue further and scale it further, right? So my question is, how can we capture the value of any program to decide the scalability for sustainability?
I've not fully understood your question, to be frank. Can you
Yeah. When
rephrase?
it comes to sustainability, you spoke about the entire industry in terms of like how can we, sustain the industry, let's say. If you get more closer, right, it means a talent development or any innovation that we do at every level, whatever that we are doing, has to sustain. It has to give more effective results, right? So in a bigger organizations, capturing that results is something I see very tricky work. So that's why I wanted to know that.
It's a very loaded question. I know it's a sustainability of a different type.
Yes.
It's not the environmental sustainability
That's right.
related.
That's right.
So we can have an offline discussion, but to your point, the aerospace engineering in general, that too aircraft engine related in particular, is a very, very complex science. There are hardly few thousands of real good scientists and engineers around the world. So we have our own sustainability challenge in terms of the knowledge development and the talent development. But yeah, we can have offline discussion. But uh, it all depends on the ecosystem. So once we have the ecosystem, the talent development becomes much more accelerated and easy. And that's something that we don't have in our country. We don't have an ecosystem of aerospace. It's still under development. So hence the talent development becomes that much more difficult.
Hello, sir. I'm Keshavamurthy from ADA, Aeronautical Development Agency. We make military aircraft, Tejas, for which you are giving the engines to us. Now, why we haven't introduced AI for real-time engine health monitoring, so that we can reduce the downtime of the engine also? Number one. Number two, any plans to introduce AI for target acquisition? And number three is on the afterburner. We have failed very badly, in increasing the afterburner thrust. So using AI, how do you sort of bring the afterburner thrust to engine weight, relation, so that we can adopt the engines 404 for our next project, and also 414 for fifth generation aircraft. Yeah.
No, I think your specific question was on the A404, I mean, our own indigenous engine and the afterburner. The larger point I just want to tell you is that AI is a game changer in solving, understanding the root cause of failure, or even, how and why it is working, if it is working, right? So the data along with the physics, the core engineering that I talked about, which is very essential, it will really help us to solve many of these complex problems. So it's not just the AI and the analytics, just the data part of it. And it is not just the conventional engineering principles and the core engineering. It's really both that would solve some of these problems.
Okay, I think we are running out of time. Probably during the lunch break, probably you can meet both of them. I'll have one last question for Octavio. Then we can wrap up. Uh, so basically, the question is: do you think we have had advances in Opus development since last year?
Well, all these meetings in ARC are like highlights for us because we expect that every year we bring new things. Yes, replying to your question, yes, we have advances, but we still have a lot of challenges. The first challenge that I'd like to highlight is that we are in the version 2.1, probably going to the version 2.2 of the standard. Because the version 3.0 is supposed to be released 1.5 years ago, was not released. We are having some challenges in terms of portability using ML, redundancy, and physical platform, some gaps that need to be solved, but is still not there. So this is one of the challenges that is not allowing us to advance more. The other point is the participation. This is something that we have a work as vendors that are involved with OPAS, which is to advocate for this technology, right? And we see the oil and gas sector very active on that. So if you want to list the main companies that are participating of that, you're going to have ExxonMobil, Reliance, Petrobras, Petronas, Aramco. So, but are the same every year. They are having their advances, they are having their requirements, so we need more participation of end users. And more than that, we need to exploit the sectors. So we are doing a job in Brazil to try to bring it to bioenergy industry, sugar and ethanol and bioenergy, because they are process control industry. But in the same time that we're trying to bring this digital architecture to them, we are having some kind of resistance in their parts even to come for digital communication protocols for their systems. So, this is something that if you get the chance to enter in another sector to bring other big end users to participate on that, I think the advances will come easily.
Thanks, both of you for the session.